Hello Geometry. This video is for volumes of one base figure, like a pyramid, a cone, any type of hexagonal pyramid, anything that has a bottom and goes up to a point like that is for volumes of those. Now, we already have the volume of any two base figure, volume of this thing. What we did was we found the area of the base and we multiplied by how tall it was. So that formula was big BH. And now what we need to do is we need to relate it to the volume of this thing. So here I have two figures that are exactly the same. They have the same base. They are the same height. And my question to you is how many of these, I'm going to fill this up with water, how many of these would it take to fill up one of these? I don't know. Let's see. This thing is full of water, and I'm going to fill it up. And there'll probably be a little bit of spillage, and we'll just deal with that. So here's one. Two. And three. Three of these to fill up one of these. And I show you that because all one base figures have a volume that is exactly 1/3 of the volume of the figure that it represents, that it looks like. And in this case, that figure is a cube. So a pyramid is 1/3 as big as a cube. I need to find my pen here. Oh, here it is. So for all one base figures, what we can say is we can say that the volume is 1/3 of big BH. And you notice that big BH, that was the volume of our two base figure, and our one base figure has a volume that's exactly 1/3 as big, so we add the third in. So formula calculations, a lot of this stuff here that I'm going to go over today, very similar. Have your calculator out, be ready to go. We're going to find the volumes of these one base figures. So here we go. It asks for volume. Volume is equal to 1/3 big BH. And the one thing I would say about this type of thing is the height. And the height goes straight down the pipe from finger to finger. From finger to finger. It does not go down the side, and it does not go down the edge. It goes down straight down the thing. So you could actually turn this thing upside down, and if you wanted to, you could run a ruler straight down here, and you could find the height of a figure. But it's basically either right down the middle or straight up and straight over if you prefer. So all right, so here we go. So we're going to go 1/3. I'm going to have to find the area of the base. I'm going to have to find the area of this pentagon, and I'm going to draw this out here like I have in the past. And on this particular one, it's kind of nice because it shows me 8. And this would be for a regular polygon. This would only work for regular bases. So if that's 8, all these sides are 8. And then it shows right there that height of the triangle is 5.5. Okay, I have enough here to go ahead and find the volume. So volume equals 1/3. Area of the base. Well, I'm going to find this one triangle. 1/2 the base of the triangle, which is 8. And the height of the triangle, which is 5.5. And that would be for the single triangle, for one triangle up in here. You could draw that triangle up in there like that. And then there's 5 of those triangles, so I'm going to multiply that by 5. So I have all of that. That is 1/3. All of this is the area of the base, and it points in their height as 30. So I'll put a 30 right here. And all I got to do is run that through my calculator. You run it through your calculator while I do mine. 1/3 times 1/2 times 8 times 5.5 times 5 times 30. And I got 1100 for the volume of this thing. 1100. And I don't have a label, but again, it's 1100 little cubey thingies. So, I mean, what are we looking for? We're looking for how many of these little unit by unit cubes, whatever that unit is, how many of those could I put in there? How many of those would it take to fill that thing up right there? You can kind of see them in there. How many of those would it take? This is a cubic unit. So I'm going to put units cubed for my label, and that's the volume. All right, let's do the next one. Volume equals 1/3 big BH. It's a square pyramid. The bottom is 12. Let's go ahead and find the total volume. So 1/3. Area of the base is 12 times 12. And the height is not 18. And here's where it's going to get a little bit tricky for you. There are times when you have a picture like this where you're going to have to drop in the height yourself. So I'm going to kind of dot that height in right there. I'm going to go down the middle and I'm going to go over. And what you're going to end up creating on a lot of these problems is you're going to create some type of right triangle in there that you're going to have to go in and you're going to have to find the height. So I'll put a little right angle there. If that is 12, that is 6. And I see a Pythagorean theorem problem to find the height. I'm going to go ahead and run through that Pythagorean theorem. I'll call this h. So I'm going to say 6 squared plus h squared equals 18 squared. Got to solve for the h, so I'll subtract the 6 squared over. And I can actually just type that in right like that. I can type in on my calculator 18 squared minus 6 squared. I'm going to do that. 18 squared minus 6 squared. And if I hit equals, I just typed it in like that. And I got 288. So h squared is 288. And then I'm going to go ahead and I'm going to take the square root of 288. Actually, 288 is 144 times 2. So this is 144 times 2. And then if I pull out the 144, I get 12 radical 2. I guess there's some value in writing my answer in an exact format like it would appear on the ACT. So that's the height, 12 radical 2. And if I was going to do this, find the exact answer, well, I know 1/3 of 12 is 4. And then I have a 12, and then I have another 12. So I have 4 times 12 times 12. 4 times 12 times 12. And that's 576. And then what they'll do is they'll leave that radical 2 just as a little kicker there. So like radical 2 on there. And that would be in units cubed. That's what units cubed. Yeah, units cubed over there. And that would be the exact answer. That's the way it would appear on the ACT. So I'm going to take now 576 times the square root of 2 on my calculator. And that decimal approximation would be approximately 814.6 cubic units would be the volume of that figure. All right, let's go down. I did that one. Let's go down to these two. So here we go. Oops. Second. All right. This one should be pretty easy right here. It actually gives you the height and it gives you the side of the base. I want you to press pause. Go ahead and find it yourself, and then I'm going to go through it kind of fast. I think I can do this one pretty good. All right, here we go. Volume equals 1/3 big BH. 1/3. Area of the base is 20 by 20. 20 times 20 is 400. And then the height is 16. I'm going to take 400 times 16. And I'm going to try to divide it by 3. I don't think it's even. Nope. So what they would do is they would leave it, that 400 times 16 is 6,400 over 3 cubic units. And if I wanted to write it approximately, approximately 2133 1/3 cubic units. And we'd have it. Okay? This one, if I named it, I would call this one a square pyramid. All right, this one over here. This one, if I wanted to name it, I would call it an oblique cone. An oblique means it's not straight up and down. It's not a right angle. We don't have a point that's directly above. But our volume is still the same. Our volume is still 1/3 area of the base times the height. So I'm going to take 1/3 the area of the base, and on this one the base is a circle. and that circle has a radius of 8. So I'm going to take 1/3 area of the base, and base would be, in this thing, it's pi r squared. Pi r squared for a circle. And then I'm going to multiply by how tall it is, and that's this height over here, which again I don't have. That's my height. But I see a Pythagorean theorem problem. So 4 squared plus 8 squared equals 20 squared. 16 plus h squared equals 400. I'll minus the 16. And I get h squared is equal to 400 minus 16 is 384. I don't think 384 has anything in it. Maybe if I try dividing some stuff out, maybe I find something, but that one's big enough. I think what we're gonna do with that is we're just gonna crank that out to a decimal. There's probably some stuff you could pull out. So let's take the square root of 384, and I got 19.6 for my height. Height is 19.6. So I take 1/3 of 19.6 times pi times my radius, and my radius is 8. 1/3 pi. Radius is 8 squared, and then times 19.6. And if you have a cool enough calculator, you can actually just string something like that in and go ahead and find the volume of it. So I'm going to do that. I'm going to do 1/3 times pi times 8 squared is 64 times, and I have that 19.6 number. I have that 19.6 on my calculator, so I just did that. And now I'm going to hit enter, and I got 1313.3. The volume is 1313.3, and that would be cubic units. Cubic units for my volume. And I have it. All right, the last problem of the day is a composite problem. Okay? And basically what I have is I have this. I have a cylinder and a hemisphere like this, cylinder and a hemisphere like this, and then I have this cone. But if you notice, the cone, like if I could shove that inside there, that cone is taking up space. Okay, it's on the inside, and what they want is they want to know the volume of this right here, the volume of this. If I took a chunk of cone out, if that cone in there and it was gone. So maybe it was something sitting there like this, and I had this cone inside, and I wanted the volume of these two together, and then the cone subtracted out of that volume in essence. So that's the formula that I'm going to write, and I'm going to write a very general formula for this. Okay, I'm going to write it as hemisphere plus cylinder. Let's write that. Hemisphere plus cylinder, C-Y-L-I-N, cylinder, plus, minus the cone. Hemisphere plus cylinder minus cone. And you may or may not have done the volume of a hemisphere. I'm just going to give you the formula right now. There'll be another video with hemisphere volumes and sphere volumes. But for right now, it's just straight up find the hemisphere, and what that is it's 2/3 pi r cubed is the formula for the volume of a hemisphere. So I'm going to write that plus a cylinder. And a cylinder is a 2-base figure. So a 2-base figure, the volume formula is big BH. Find the area of the base times the height. And then I'm going to subtract off the cone, and the cone is a 1-base figure, and that formula would be 1/3 big BH. So that is a very general formula for the volume of this thing. Okay? Let's see if we can go through and we can throw numbers in. So we got 2/3 pi, and then the radius. Well, it's showing the diameter of 10, so that means my radius here would be 5. And actually the radius of everything here would be 5. So here we go. 2/3 pi, 5 cubed, plus the cylinder base. Base of a cylinder is pi times the radius, 5 squared. That's big B, pi r squared, times the height of that cylinder. That height of that cylinder would be right there. Right there. The height of that cylinder is 15, minus 1/3 Big B for the cone is area of the base of the cone. Again, that's pi r squared, so pi 5 squared. And then I'm going to multiply by the height of the cone, which again is 15. And I'm going to see if I can simplify this down without actually hitting any calculator buttons right away. And let's see what we can get. Maybe we can do some math here and we can get an exact answer. So I have 2/3 times 5 cubed. 5 cubed is 125. So 5 raised to the third, 125. And then I'm going to multiply it by the 2. 125 times 2 is 250. And then I got 250 over 3 and a pi. See, I put that together with that, and I got 250 over 3 pi. That's the exact volume of the hemisphere. Plus, 5 squared is 25. 25 times 15 is 375. So here I have 375 pi minus, and again I have 25 times 15, which is 375. This time I have a third of it. So I'm going to take 375 divided by 3, and I get 125. So minus 125 pi. And if I wanted to put this together in terms of 1 pi, I would take 250 over 3 plus 375 minus 125. And I'm just going to do that right on here. So I'm going to do 250 divided by 3 plus 375 minus 125. And I got 33.3 repeating. And I can turn that into a fraction by just hitting math frac on my calculator. And I got 100 over 3, or 1,000 over 3 times pi. Or you could write it as 33 1/3 pi if you wanted to. Or 333 1/3 pi if you wanted to. Okay, that would be fine. Let's go ahead and write the exact answer. I'm going to make that times pi. Or this is the exact answer, the decimal approximation would be 1047.2. And it's set in feet, so that would be in feet cubed. And I have it. All right, good luck with your assignment.